Morning, everybody. Welcome to Module 2 of our math unit. Mr. Sorori took you through the last 3 lessons on coordinate points, and what's kind of unique about this unit is it just doesn't continue with coordinate points. We now switch over to a completely different idea, which is classifying different types of triangles and other types of polygons. So what we're going to use here is a structure called a hierarchy. And I wrote over here a couple examples of some things that you might be familiar with that are in a hierarchy. Things such as the military, like who works underneath who. You've got generals and lieutenants and sergeants and all those people who work in the military. Another example is your address. The way that mail gets to your house is it's through a hierarchy. First it looks at what city is it going to, what state is it in, what zip code is it in. And once it kind of gets into that realm, then it goes into your street address and then the number of that street address. And if you live in an apartment, even what apartment number that you're in, so that the mail is going to the right spot. Living things, if you're really into science, classification of animals. Some of you might have learned that there's such a thing called the kingdom, the phylum, the class, the order, and I'm forgetting the last couple steps. But all of those animals that are in the wild, domesticated, they all come from these different hierarchies. And the last thing that you might think of a hierarchy might be like something like a family tree. So if you put grandparents, your oldest relatives on top, they had brothers and sisters, those brothers and sisters had kids, those kids are either your parents, or they're your uncles, or they're your great aunts and uncles, and you have your cousins and your siblings, and all those things work in a hierarchy. So what we're going to work on is a hierarchy of the polygons. And a polygon is any shape that is a closed shape, which means if I draw a non-closed shape like that, that's not a closed shape, so it doesn't count as a polygon. And it has 3 or more sides, because if you have just a 2-sided shape, that doesn't work. Some of you might be thinking, ooh, I can draw a circle. So a circle is not a polygon because it doesn't actually have 3 or more sides. It just has one continuous side. So what I have listed here are the triangles, quadrilaterals, which for those of you that are like, what's a quadrilateral again? Those are the 4-sided shapes. We have pentagons, and then we have hexagons, so 5- and 6-sided shapes. And this hierarchy could continue on with octagons, nonagons, decagons, and it could keep going all the way. Just for time's sake, and we're only going to talk up to hexagons through this unit. So we're going to ignore this entire half right now. We're going to focus on the triangles. I remember last year I talked to your 4th grade teachers, and they did say you guys started talking about triangles and how you can classify them. So triangles can be classified in a couple different ways. So right now, just kind of think of them. What were some of the ones that you talked about? Yep, acute triangles, good, way in the back. Yep. Right triangles, yep, that's another good example. Yes, the one that has all sides the same, yep, those are called equilateral triangles. Okay, good, so you guys are remembering a little bit of that. So what I'm going to do is we're going to talk about the different types of triangles that we can classify, and what I want you to do is I want you to write this down as well. So at the top, have polygons, have triangles. You don't have to do quadrilaterals, pentagons, or hexagons for today. So just have polygons at the top of the hierarchy. Underneath that is going to be triangles. So as some of you were mentioning, there's 3 types of triangles that we can classify by the side lengths. The first one is known as an equilateral triangle, which is when all the triangle's sides are the exact same, equilateral, same length. If you want to play around with some of these triangles as well, on your apps in the bottom left corner, you're going to go to the GeoBoard one, and you'll be able to pull up either the 4x4 or the 5x5 I think you have, and you can start pulling and making different shapes and different triangles, and that's going to be really helpful for the student book pages that you have to do later today. So I encourage, after this video is done, get that out, start playing around with it, and then you'll be able to copy what you make onto your student book. All right, so again, triangle, underneath that is the equilateral triangle, EQUILATERAL. And again, that triangle has all 3 sides of the same length. Another one that we have the isosceles. ISOSCELES. We have the isosceles triangle. So an isosceles triangle has two sides that are the same and the one side of the triangle that is different. And the last one that we have over here is going to be called a scalene triangle, SCALENE, for those of you writing that out and wanting to spell it correctly. A scalene triangle doesn't have any sides that are the same length. Each side length of that triangle is different. Okay, so this is going to be classified by their side lengths. The other thing that we can do is we can also classify triangles by their angles. Some of you are thinking the acute triangle, the obtuse triangle, or the right triangle. And what's really cool about this hierarchy is that it actually builds on itself. So polygon is any shape that has three or more sides. That's a closed figure. Triangles, this is more specific. It has three sides. An equilateral, all three sides are the same. Isosceles, two are the same. Scalene, none are the same. Then what we can do is we can get even more specific and talk about what type of isosceles triangle is it? Is it possible to have a right isosceles triangle? And the answer is yes, you can. The only one that's kind of unique is this equilateral one, because no matter what happens with this equilateral triangle, it's always going to have the exact same angles. So whether I make this triangle really small and all the same size, or whether I make this triangle really big, that angle in here is always going to be, fun fact, 60 degrees. The inside angles of a triangle are always going to add up to be 180 degrees. And an equilateral triangle, all three of the angles are going to be 60 degrees because 60, 60, 60, that gets you the 180. All of these triangles are going to be the same, but because they're not equilateral, they're going to have different angle amounts. All right, so we erase this picture here. You can keep that if you want on yours. I just need all my space on my board. All right, so we have our isosceles triangle. We can have an obtuse isosceles. And what that means, an obtuse angle is one angle that is greater than 90 degrees. So an obtuse isosceles triangle is going to have two sides that are the same length, and one of the angles is going to be greater than 90 degrees. So as right here, two sides are equal, and one angle is going to be greater than 90 degrees. I should change this for the word angle. All right. The second type of isosceles triangle that you can have is an acute isosceles triangle. Again, the two sides are equal, and all angles are less than 90 degrees. So what makes something acute is that it is less than 90 degrees. And if I have my obtuse one where one angle is going to be greater than 90, my acute one, they're all going to be less than the 90 degrees. The third type is going to be a right isosceles. You're going to have two sides that are equal, and one angle is going to be 90 degrees exactly. All right, so 90 degrees, for those of us that are like, well, I don't know what that looks like. If you put one arm straight up, put the other arm right here, you have created a 90-degree angle. Okay, almost like a T, put it this way, or think about like an L. Excuse me. That's going to be at 90 degrees. Anything greater is going to be going this way. Anything less than is going to be going this way. All right, it's kind of like on a sundial. As the sun goes around, shadow gets longer and longer. Start here at the 0 degree. Here's 45, 90. Anything greater than 90 makes it obtuse. All right, so scalene is the exact same thing. We have all three of those options. So we have obtuse, scalene, we have acute, scalene, and then we have right. So everything is going to be the same here, except the scalene, no sides are going to be the same. So there's going to be no two sides are equal, all three sides are unique. One angle is going to be greater than 90 with the obtuse, all of the angles will be less than 90 with the acute, and one angle will be greater than 90, or will be 90 degrees exactly with the right. All right, so copy this hierarchy down. You're going to use this for the next couple days. This is going to be something that we come back to and we refer to frequently. So that's it for today. You're going to be using that GeoBoard app to start building some of those angles, and that's going to be at student book page 224. To fill in those pages, you'll need the help of that GeoBoard potentially, and then your home connections for tonight are page 119 and 120. All right, excellent. Again, if you missed any of this, rewatch it, go back. Hopefully you've paused throughout as we went. Reach out to your teachers with any questions, and always make sure that when you're done, take these pictures of these pages and submit them on to your teacher. All right? Thanks, guys. We'll see you tomorrow.